Hello everyone and welcome to today's webinar, Disaster Recovery Using Amazon Web Services. Before we get started, I want to mention that you have joined today's webinar muted. You can ask questions in the question panel of your GoToMeeting control panel. We'll be answering as many questions as we can at the end of the presentation. And with that, I'd like to get started. So hello again and thank you for joining us today. Over the next 45 minutes or so, we'll be discussing disaster recovery approaches and how Amazon Web Services can be used to implement DR in the cloud. My name is Stelio Dallo and I'll be your host for today's webinar. I'm part of the AWS marketing team here in Seattle and I look forward to our time together. I'm excited to be joined today by our featured speaker. Many of you are familiar with Jeff Barr, our senior evangelist in AWS. Jeff spends a lot of time on the road in public speaking engagements with sometimes squeezed in between the blog on the AWS blog and write books, publish papers, and otherwise share great stories with our customers and everyone else who's interested in all things cloud related. Welcome, Jeff.
Thanks for having me.
All right, so here's what you can expect to learn from today's webinar. Some of the things that we're going to be covering is allowing you to determine whether a cloud-based DR strategy is right for you, how to implement some common architectures, the services that are most relevant to implementing backup and disaster recovery with AWS. And Jeff's going to point you in the right direction in order to learn more, or if you're ready to get started. So let's start with some of the reasons why using the AWS cloud for your disaster recovery needs may be compelling to you. It's entirely possible that you'll be able to slash parts of your DR budget by up to 50%. Some of our customers are saving over 50%. Entirely feasible to eliminate a third or over 30% of your on-premises IT footprint, in particular on the storage side. Chances are good you'll be able to eliminate the need for a physical second site. We have a lot of customers that implement disaster recovery with a physical second site, and there are ways to obviate the need for that, and we'll be talking about that. And a common use case is the ability to eliminate tape for backup and archive, and we have customers certainly that have done that. So whether you are using tape for backup and archive now or you're contemplating going in that direction, hopefully you'll learn how we might be able to help with that as well. So what I'd like to do to begin today is run our first poll question. We'll have a number of polls that will give us some real-time feedback from everyone in the audience. And the first poll question for you is, which of the following workloads is your organization considering moving to the cloud in the next 12 months? So let me just bring that up and launch that poll. And I'll give everyone around 10-15 seconds to answer. And of course, you can select more than one option. And let's see where everyone is. The results are coming in. Thank you very much for that. Still coming in. Interesting. Excellent. Okay, we still have results coming in, so I'm going to give it a little more time. Okay, I'm going to close the poll in 3, 2, 1. Thanks for everyone who did reply, and let's take a look and see where we are. So very interesting. It looks like a lot of the people on the call today attending the webinar do have an interest in moving workloads over to the cloud, and certainly, as we might expect, quite a bit of it is around archive and backup. So that's great. So there you go. Now you know where you are in relation to your colleagues as well. So with that, let's start with where DR fits into your continuity plans overall. So it's really part of a business continuity continuum. And I'd like to point out also that implementing DR is not an all or nothing proposition. You can work your way across a continuum. Today we'll discuss some of the things to consider and how AWS can play a part. So the starting point is usually thinking about how to keep your applications up and running. It's probably subject of another webinar, but you'll have a requirement in the form of how many nines of reliability you need, keeping in mind that for every 9 you add to your HA strategy is probably going to add quite a bit of cost, often around 10 times for each additional 9 after the first few. The next thing you're likely to plan for is how to back up your data so it's safe and available to you in the event of a disaster. And that's one of the things we'll be talking about, and how you store that data so first of all, it's durable, and then secondly, it's available to you when you need it. And then you need to have a plan for what to do in the unlikely event that you have one of those black swan events where a true disaster occurs, and how you deal with that recovery. So disaster recovery is at one end of the continuum, and how you choose to implement is influenced by your requirements with a couple of things. How long you're able to be down, and that's your recovery time objective, or RTO, and how much data you can tolerate losing, or how in sync does your backup data have to be with what you have in your operating environment. That's your recovery point objective, or RPO. So RTO, RPO are two terms we use throughout the presentation today, and they're key. And then you'll start to think about the requirements for different types of outages, say from restoring a file that was accidentally deleted through to how you handle a complete system outage due to a natural disaster. And we had a lot of those incidences worldwide this year, unfortunately. So it's at the forefront of a lot of organizations planning for this year and next. Now, a common path to the cloud is to start with backup and recovery plans using the cloud for your backups, and then identifying the applications that are candidates for you to implement a full DR plan with the cloud. So any app that you can run in the cloud is low-hanging fruit for you. Replicating the full stack would be the more complex and involved end of the scale. But that's, generally speaking, the on-ramp for most organizations in terms of moving over and utilizing the cloud increasingly. So you have a lot of flexibility in how you approach the solution that fits you best. And Jeff is going to talk about what some of those architectures look like and how you can implement them. I just want to make a couple of last points before I turn the webcast over to Jeff. First, let me mention a few sample implementations to you. We get asked a lot about who's doing what, so I do want to share this with you. It'll give you some examples from our case study page and our website, and you can certainly get more information in terms of what fits you best by talking to your account rep or one of our solution partners. But at the end of the day, AWS is being used to implement DR strategies in a variety of ways in organizations of all sizes. Here we have listed a few examples. One is a system integrator. We have a disaster recovery solution provider, a manufacturing company, and a digital media company. Each of these implementations represents a solution tailored to meet a unique combination of RTO and RPO drivers. So there are customers using AWS in a number of ways, from backing up and restoring web apps through to cold, warm, and hot standby for business applications like Oracle, e-Business Suite, SAP, and SharePoint. Okay, one last thing before I turn over to Jeff. I want to explain, we're often asked, how is it that some customers are able to reduce costs as dramatically as the claims I made earlier, while still getting the performance, the recovery performance they need? That's a great question, so I'll take just a minute to point out, in simple terms, one of the ways that can be accomplished. So clearly, when you're running a system in your data center, you require a full stack of infrastructure to have that occur, right? You've got everything from your servers, your storage, your archive software, backup tapes, your network, your routers, firewalls, and so forth. Admins, a lot of admin work. You have your real estate, your ping power pipe, and you require that to run. So that makes sense, and that is what it is. Now, if you have a requirement for DR, for a lot of organizations, what that calls for is a second site. So you need a second data center or a colo, and you've got to replicate that full stack in order to be able to fail over to it. So of course, it's not going to be one for one. It's going to be provisioned adequately to allow you to run after you fail over for a period of time, but you are carrying a lot of overhead with that. The fundamental difference when you move to the cloud is, for the most part, your backups are just that. They're snapshots that you're storing, and that can be snapshots of your applications, your executables, and primarily your data. But the key thing is you're not replicating all that infrastructure, and you're only paying for the amount of storage that you use. So that, in and of itself, that's one use case where a number of customers are realizing substantial savings right off the bat, and hopefully that helps drive home how valuable it can be to transition your strategy to use the cloud. Okay, with that, I'm going to have one more poll question before I turn over to Jeff. The second poll question for you is, if you are planning an implementation, how do you think you would go about it? I mentioned a number of use cases, a number of ways of getting over to the cloud, and it'd be interesting to know when you do that. For the people on the call today, would you typically do that on your own? Would you hire someone in full-time to do it? Work with one of our many solution providers or system integrator? So I'm getting a lot of input on this. Okay, it's really interesting. So I'm seeing the results coming in. They're still coming in. I'm going to let it run. This one's a little bit more lopsided than the previous answer in terms of selection. And I'm going to cut it off in 5, 4, 3, 2, and 1. Okay, so here are the results. Interestingly enough, and Jeff, this might help you in terms of how you elaborate on some of the architectures, because it looks like most of our audience today would plan to implement on their own, so they need some good, tangible, accessible strategies, and we'll focus on those architectures and mechanisms. But it's also interesting to see then we do have a large number of clients that would be working with partners, and we'll talk a little bit about that as well. Okay, very good. So at this time, I'd like to turn the microphone over to Jeff, who will discuss AWS service and architectures and point you in the right direction at the end of the webinar. Jeff?
All right, thank you, Stelio, and thank you all for coming. I always enjoy speaking about AWS, and I really am actually enjoying looking at the questions and comments that are already flowing in. So please do your best to keep those coming, and we'll absolutely do everything we can to respond to all of those questions. So I'm a senior evangelist here at AWS. I've been at Amazon for almost 10 years. You might know me for the Amazon Web Services blog, which is at aws.typepad.com. I think one of the important things to start when you start to think about disaster recovery is to really know that AWS has a global infrastructure model. We publish a global infrastructure map, and on that map we show you several different important things. We show you in the orange boxes, we show you the locations of the AWS regions where we have compute, storage, database, messaging, and so forth. And we also show you the AWS edge locations with those red circles, which indicate the locations of our content distribution and our DNS service edge locations. It's extremely important for you to know that when you choose to store data, process data in the cloud, you have complete choice and control of where that happens. If for reasons of latency or legal reasons or just personal choice, you need to keep your information in the US, you have the choice of multiple AWS regions in the US. If for other reasons you say, I need to be close to my customers and my customers are in the Far East, or if they're in Europe or they're in South America, you can choose among those regions. And it's really important just to know that once you make the choice of that region, that is where all of your processing, all of your storage will take place. It's only with your explicit command and consent that we would ever move information from one region to another. As you can see from the map, there are currently 8 separate locations, 4 in the US, including what's called the AWS GovCloud that's reserved for government customers and applications. We have a region in Portland, another one in San Francisco, and then the 4th one is located on the east coast of the US in Northern Virginia. Our newest region is located in Brazil. There's a region in Ireland, and then both Tokyo and Singapore. So this is our current map. We actually added 4 of those regions just in the last year, so you can trust that we will continue to add additional regions to that map over time. Within each of the regions, we have a further subdivision that we call an availability zone, or an AZ for short. When you choose to build your application, we strongly recommend that you distribute your functionality across 2 or more availability zones in an individual region. Each of the zones in a region is equipped with its own physical security, network connectivity, power, cooling, and control infrastructure. The design model is that any local event that might affect a single availability zone is going to be isolated from the other availability zones in the same region. We give you full control, again, like you have control of the regions. You have control of the ability to launch your servers, your EC2 instances, in any of the availability zones within a region. We give you services such as automatic scaling and load balancing to also let you distribute functionality across the zones in a region. So we often get asked about security, and in the past I used to leave this information for late in the presentation. I found that it's actually very helpful to cover it up front so that we address the security questions that invariably arise, and that way you don't have to kind of keep those in mind for later. So we've really built AWS to make sure that we're meeting enterprise-level security standards. Over the last years, we've invested very heavily in a number of certifications, as you can see listed on the slide there, from things like SOC 1 Type 2, formerly known as SAS 70, ISO 27001, PCI DSS for a number of the services. For government apps, we have things like FISMA Moderate and ITAR. And we have a number of customers building HIPAA applications in the cloud that must process sensitive personal information. We take strong precautions with respect to the physical security in our data centers. The data centers are all housed in very nondescript facilities. You will never ever see a blinking light on top of or a blinking sign on top of an Amazon data center that advertises what it is. It's just a bland, plain building. Physical access to the data centers is very strictly controlled. There's just a very few employees that are allowed in and out. And those employees have to pass through at least 2 levels of two-factor authentication to get access to a particular floor of a data center. All of the access to the particular areas of the data center is logged and periodically audited. And all of these details, if you need to know more about any of these particular things, we do publish a security white paper available from our website. And then at the hardware, software, networking level, we're extremely methodical when it comes to change management. We have a very well documented and controlled procedure. When we roll out changes into the various systems that comprise AWS, those are always done on a phased model. They're always done on a part of an availability zone at a time. And then as we roll those out, we carefully test those and then roll those out across the remainder of the network. We have a set of documented procedures for decommissioning storage, including degaussing magnetic devices and then shredding them into tiny little bits of metal and plastic. There's a number of automated monitoring and auditing facilities built into the system as well. Again, if you have any questions about these, please feel free to enter those questions, or I would also refer you to our security white paper. I'm going to mention a number of different AWS services today, and I'm not going to go into great detail about any of them. I do just want to establish the vocabulary up front so that you do know what I'm talking about. We're going to be talking about the simple storage service, often known as Amazon S3. We'll talk about import-export, the ability for you to mail data to us on a number of different storage devices and have us import it into the cloud for you at internal network speeds. I'll be referring to Amazon EC2, the Elastic Compute Cloud, which gives you the ability to launch virtual instances on currently 11 different types of instance types with varying amounts of CPU power, RAM, network connectivity, and so forth. I'll be referring to the AWS Storage Gateway, which is one of our newer offerings. This is a software virtual appliance that you install on-site in your data center, and it creates a storage gateway between your local storage and the AWS cloud, making it very, very easy for you to store data locally and have that data automatically replicated and backed up to AWS. And finally, I'll also be referring to Amazon Route 53. Route 53 is our DNS, our domain name service, and this takes care of mapping domain names to IP addresses. As we'll see in just a little bit, the ability to switch DNS entries rapidly is actually a really important part of a disaster recovery model. Let's start by talking about storage. So our different facilities are designed for different types of backup and disaster recovery. The first one, Amazon S3, is designed to offer very highly durable blob storage. So by highly durable, I mean we've designed this to offer 11 nines of durability. And that means if you store 10,000 objects with us, we expect to lose one object about every 10 million years or so. S3 is designed to be excellent for backup and archive. Because it's blob storage, you're always storing entire objects in S3. There's no concept of updating an S3 object. You're always storing entire objects to us. Those objects can range in size from a single byte on up to 5 terabytes. The other type of storage is called elastic block storage, or EBS for short. And when you have these EBS data volumes, you can create these in any size from 1 gigabyte up to 1 terabyte. These are persistent data volumes that you create and then attach to any Amazon EC2 instance in a particular availability zone. There is redundancy behind each elastic block store volume, and they do have a published reliability and durability figure for them. When you have data stored on an EBS volume, we give you facilities, and we also encourage you to make snapshots of that data. When you create these EBS snapshots, you can then use those to recover the data volumes with just a single click in the AWS Management Console. The snapshot backups are actually stored in Amazon S3 and give you the long-term durability and also the ability, as I said, to recreate these volumes within a region. So an essential part of your planning and your thinking when you start to think about DR is to choose the proper types of storage. We just announced some new numbers yesterday for Amazon S3 and got a lot of really, really great coverage of those numbers. As you can see from the right-hand column on this chart, at the end of the fourth quarter of 2011, we're storing 762 billion objects in Amazon S3. We also process over 500,000 requests per second for those objects. Now, also keep in mind when you look at this that there's redundancy behind the scenes in Amazon S3. So these are actually customer objects, and S3 behind the scenes is keeping multiple copies of these objects and transparently recovering from any issues that might arise. So we talked about storage, and now let's move over to talking about how do you connect from your data center up to AWS. Like a lot of different parts of AWS, you have multiple options and multiple ways that you can choose to design and implement this. The most straightforward and obvious way is to simply use your existing internet connection from your corporate data center up to AWS. That's great if you have a lot of a high bandwidth connection, if you have a 1 gig or 10 gig connection. That's kind of the most obvious and most straightforward way to do it. If you are, for various reasons, you are not in a position to send that data out across the internet, we offer a service called AWS Direct Connect that allows you to establish a private networking connection from your data center to AWS. You can do that with either 1 gigabit or 10 gigabit bandwidth, and full details on how to do this are available on your website. The final option is called AWS Import Export. With this service, what you can do is within your data center, you can write your data onto a variety of different magnetic and flash-based storage devices, and then you physically ship those devices to a particular AWS region. When we receive those devices, we will unpack the data and we'll store it in the S3 bucket of your choice. When you actually set up your import-export job, you include a manifest file to provide full details of what you would like us to do with your data. So these are 3 different options you have for getting your information up to the cloud. Another option is brand new. This is called the Storage Gateway Service. And we put this together because we saw a lot of enterprises wanted a very clean and very straightforward way to merge their existing data center and all the benefits we've already talked about AWS. With the Storage Gateway Service, what you do is we provide you with a virtual appliance, a software appliance. You install that on a host in your existing data center. And within that host, you then configure various disk volumes that represent your existing direct attached or storage area network disks in your data center. You configure these disks, and you then configure the gateway such that it can back up these disk volumes up to AWS. The backups are stored in S3, and you then have the ability to create EBS volume snapshots and use those snapshots to then create actual EBS disk volumes. The really wonderful thing about this is that your applications that you're currently running in your data center are storing on those local disks just as they have done in the past. But then you've got this backup that's happening for you transparently and automatically from your data center up to the cloud. Let's focus on a few other networking and security concepts before we dig deeper into disaster recovery. As I described it just a few slides ago, the AWS Direct Connect lets you create a dedicated connection between your data center and AWS. You could do this for reasons of privacy, or you might want to do it for regulatory reasons. You might do it to make sure that you have a controlled amount of bandwidth between your site and AWS. Whatever the reason, you have this ability to create this connection. You initiate this process by simply filling in a form on our website. We'll work with you, we'll work with your existing data center, your colo providers to get this connection established for you. The next service you should know about is called the Virtual Private Cloud, or the VPC. The VPC lets you take the existing AWS cloud and then create a walled off section of that for your own use. Now, by walled off, what does that mean? What that means is you're able to create this object called a VPC. When you create it, you assign it an IP address range. You then break that IP address range down into subnets, just the same kinds of things you would do if you were building your own corporate network from scratch. You break it down into subnets. You get to establish access control rules. You get to put virtual routers between the different subnets. And you can even control the routing tables that control how the traffic is able to transit from subnet to subnet. You can then create a VPN gateway from your data center across to your virtual private cloud that you create. So in effect, what you've done, you've created this virtual extension of your local data center. You've attached it to your data center. And the AWS resources that you launch inside of this virtual private cloud are then accessible to your data center almost as if they were on your local network. So this is a wonderful way to take the often limited resources that you have inside your current network and then extend those with additional resources in the cloud. The final thing you should know about when we talk about security is called the dedicated instance. So with the dedicated instance, what you're able to do is you're able to launch an EC2 instance with a special designator on it that simply says, I only want virtual instances from my own organization to be run on the same hardware. So again, we often come back to regulatory requirements that say there can't be any sharing of the host hardware between different organizations. If that's a concern to you, at the point when you decide to launch the virtual instances, the EC2 instances, you simply check one checkbox and say, I'd like that to be a dedicated instance, and we will then, behind the scenes, make sure that we're running on hardware that's only available to your organization. Now let's shift into some common architectural patterns for disaster recovery. There are really two different options that we can talk about here. Let's say you're already running in AWS. What does disaster recovery mean there? And then what does it mean if you're running currently in your own data center and you want to do disaster recovery to AWS? So in the first case, you're already running inside AWS. This is kind of if you already have a cloud-native application, effectively what you're doing is you're simply building a high availability architecture inside AWS. So you're going to have multiple instances distributed across several different availability zones. You're going to have an elastic load balancer to spread traffic out across those different instances. You'll have a disaster recovery strategy that says if things fail, if instances fail, how do I replace them? Which often the disaster recovery strategy in the cloud-based model, a lot of that can be covered simply by using auto-scaling to say if an instance fails, I need to boot up a replacement one in its place. When you're running fully in the cloud, you have the ability to rapidly restore and even completely fail over fully inside of AWS. This could be inside of a single region, or in the more advanced case, you might even start thinking about, do I want to actually build applications that are able to fail from a single region to a different region? Let's focus more on the second scenario right now. The ability, if you have an application running in your own data center, what do you do to create a disaster recovery model from here? So the idea is you're certainly going to start with your own high availability architecture. You're going to come up with your DR strategy for how live you want to be. As Stelio talked about earlier, we're going to talk about recovery time objectives and recovery point objectives. You need to have a good understanding of your requirements there and of what your business's requirements are there. And you're also going to think, so phase one of of the disaster recovery model here would be you're going to go from your on-premise up to the cloud. You're going to then start to make sure that your on-premise is restored to operation, and you'll then do the reverse case. You'll switch from AWS back down to your local data center. So we're going to talk about how you can rapidly fail over to AWS while you're putting your on-premises infrastructure back together. Now, one really cool thing that some of our customers have learned when they implement this model, they say, well, now that we have the data up and running inside of AWS, what else can we do with it? And one often kind of expressed kind of thing we hear is, well, I can start running some analytics in the cloud. I can spin up a whole bunch of EC2 instances. I can maybe run an elastic map reduce job and do large-scale parallel processing. But it's actually a really good eye-opener for people when they start to think about, now that I'm running in the cloud, or at least I have my data in the cloud, what else can I do with it now that it's there? We see 4 separate architectural patterns, and we're going to talk about 2 of those in detail today. So let's focus on the backup and restore model, and on the Pilot Lite-based model for quick recovery into AWS. Let's dig into both of those and see what's inside. So backup and restore, what does that mean? Very, very simple and very, very straightforward to get started. Yeah, generally very, very cost effective. You're not paying for anything besides the backup storage that you consume. And what does it take to get started here is simply you're taking backups of your current systems, which you are undoubtedly already doing. And instead of storing those locally on tape, you're just going to upload those into Amazon S3. The real preparation phase, all you really need to do to get going here, figure out what your procedure is to take the backups from S3, and then pull those back down into your local systems. So relatively simple, very, very straightforward. Often this use case and this pattern is generally the first kind of big step a lot of organizations will take to get in the cloud. They get up and running. They start to realize that a lot of the former expenses of dealing with tapes and tape drives and devices that seem to go obsolete every year or two, they don't have to think about those kinds of things anymore. And they say, we don't have to worry about limited capacity, limited space, expiring old items, and so forth. You put those things in S3, and S3 will take care of all those details for you. So schematically, what does that mean? On the left, we have our traditional server running in your data center. And we're either going to directly copy that data up to an S3 bucket across the internet, or perhaps for whatever reasons, we're going to use the import-export to send that indirectly. So if you're already writing data to local devices, perhaps the easiest way to work S3 into your operating model to simply, instead of sending those devices off-site to your existing archiving location, you can send those to us instead, and we'll then copy them into the cloud for you. An important part of this component of this architecture, and something we'll get into more detail later, is the fact that Amazon Route 3 is doing the DNS hosting for that server. And we'll see how that actually comes into play in just a little bit. What happens in case of a disaster? 2 different kinds of models here. So if the disaster was something that left your local infrastructure running, you would simply retrieve the backups from S3, put your infrastructure back into place, and restore your system from the backup. That could either be restoring to on-premise infrastructure or restoring to AWS. Needless to say, as we talk about all these disaster recovery models and modes and architectures and so forth, you always want to design these systems out. You want to actually have a simulated event to make sure that you understand exactly what to do in case of a disaster, and then revisit the backups periodically, make sure that you're backing up the proper information, make sure that it's very well documented exactly what you need to do in case something goes wrong. So here's a schematic to show you what it's like to restore from AWS. In this particular case, what we're doing is we're restoring from S3 to an EC2 instance. We're going to have a couple new vocabulary items here in this particular picture. So let's say you've been dutifully doing your backup to Amazon S3. You've got a number of objects stored in your S3 bucket. The unthinkable happens, and you suddenly need to put your disaster recovery plan into place. So now what you're thinking, you're saying, well, my local data center is inaccessible to me. It's not able to be used for my recovery. I'm going to recover over to AWS. What you need to be able to do at that point is you need some processing power. So what you're going to do, you're going to be able to launch an EC2 instance, which is simply a virtual server running any number of different varieties of Windows or Linux. And to do that, you need this very, very special piece of information called an AMI, or an Amazon Machine Image. An AMI is essentially the gold disk for your system. And when things are going well, you would be creating this AMI. You'd put your operating system, your applications, your tools, all of your configuration information into place in that AMI. You store that in the cloud. And at the point when you say, I need to recover to the cloud, you simply launch one or more copies of that AMI onto EC2 instances. From there, you take the data stored in your bucket. You restore that to the local disk volumes of your instance, and you'll be up and running again, this time in the cloud rather than on-premise. Now let's move to the more complex architecture, which we call the pilot light model. The idea with the pilot light model is we're going to be always sending our data up to AWS, keeping the cloud-based backup in very, very close to up-to-date condition. So we're going to have a very, very low recovery point objective, low meaning that it's a very, very small amount of time. And we're then going to have just kind of a very moderate amount of processing running in the cloud until we actually have that, put the disaster recovery plan into place. At the point when we say, well, we need to go into recovery mode, we're going to scale up the system as needed to handle the amount of traffic that comes in. And we'll then switch over to this whole new system running inside of AWS. This page shows you the normal operating conditions. On the left, we have the on-premise application stack. We have a database server, we have an application server, and a web server. And two very important aspects of this diagram. We're either mirroring or replicating data from the local database server up to the cloud. In either way, we're maintaining a live, up-to-date data volume in the cloud. That's important point number one. Second thing is that we're using a DNS server. In this particular diagram, we're using Route 53 to map the particular name of the website to the IP address. In normal operating conditions, we're pointing that at the on-premise web server. So far, so good. In the cloud, all we're running in the cloud, we have a data volume and a modestly sized database server, just big enough to take that replicated data stream and store that on the data volume. We have machine images set up for both the app server and the web server, but those are not running and those are not consuming any processing power. They're not costing you anything to have those. All you're paying for at that point would be storing the machine image. You wouldn't be paying for the instances because they're not running. So something happens, what do? We lose our local system. Momentarily, our DNS is still pointing to the web server, which is now defunct because we've lost our local system. What we quickly do, we take those AMIs that we've carefully put together, we launch our application server, we launch our web server, and we retarget our DNS. So we point it away from the on-premise web server to the newly launched web server running in the cloud. Generally, if you're going to do this, you'll want to set what's called the TTL, the time to live on your DNS entries, to be a very, very low number so that you don't have clients out on the web that are trying to still access the old server. And so the other important aspect of this, that database server in the cloud, you'll want to scale that up from the small size instance you were using just to kind of catch that replication up into a production capacity. And you can do that very, very easily with a cloud-based model. So here you see that we were running locally, we failed over, we mapped over the DNS, and we're up and running in the cloud. To wrap things up a bit, let's take a look at a few of the benefits to doing disaster recovery with AWS. It's highly durable. We talked about the fact that S3 gives you 11 nines of durability. As Stelio pointed out, the cloud-based DR model drastically reduces the amount of infrastructure that you need to have. And especially when you start to think about it, a lot of that infrastructure is just simply sitting there idling, waiting for the unthinkable event to happen. So you're effectively paying money for things that you never get to use. The cloud-based model flips that around and says you're going to pay only for what you use. We have easy distribution, so you can choose the region that you'd like to process. And as we talked about, you currently have 8 different AWS regions around the world. You can easily scale this up and spin things down as needed. One really good aspect of this means you can very easily test your DR plans, and I would always recommend making that testing just a regular part of your business practices. And every quarter, let's say, you're gonna go through your DR plan, you're gonna have a simulated pulling of the plug, and make sure that all your plans are actually going to work as expected. We talked a bit about security, and I would encourage you to take a look at our security white paper if you do have any security questions. Really important for you to know we have a number of different solution provider partners available to you to work with. As you can see, probably some brand names that you recognize here on the slide. Please feel free to check out our website if you need any more information about any of these partners. We'd be happy to chat with you privately as well and connect you with them if necessary. Here's a number of links for you to find the slides, to find more information about our webinars, our videos. We have a special disaster recovery webpage for you. My blog is at aws.typepad.com. We've got white papers, we've got partner links as well up there and available to you. I would also like to mention that on February 23rd, we'll be running our next webinar. We'll be talking about the AWS Storage Gateway in a lot more detail, and the registration link for that is shown on your screen. I'm sure we'll also email that out in our follow-up. With that, I'd like to hand things back over to Stelio.
Great, thank you. Fantastic. Thank you so much for that, Jeff. I'm sure everybody got a lot out of that. Before we cut over to live Q&A, I would like to ask one more poll question, and that is, let me launch the poll. So with what you've learned so far, are you more or less inclined to implement DR in the cloud? Be really interested on your sentiment now that you've learned more about your options and what it takes. Great, thank you for everyone. Getting a lot of replies, so I'm going to let it run a little bit longer. That's great. Thank you for everyone who's taking the time to reply. Okay, I'm going to close it in 3, 2, 1. And share the results as soon as they are tabulated. And here they are. Okay, good feedback. So it sounds like the information was bang on. It's giving you what you need to be able to make your decision. So that's great. Okay, thank you so much for sharing that. All right, let me get that out of the way. And okay, we are now going to go to the Q&A session. So we've got about 10 minutes or so for Q&A. We will thank you for those that have submitted questions in the question panel. Again, for participants, if you put your question in chat, we're probably going to miss it, but it looks like everyone's been putting them into the question panel, which is great. So at this point, Jeff, would you like to select a question, or would you like me to feed one? I can pull one for you while you're bringing that up. Okay, so one question. How do we ensure the backup pipe from the data center to the AWS cloud is adequate?
Tell me that one again.
Okay, how do you ensure that the backup pipe from the data center to the cloud is adequate? How do you kind of test for bandwidth?
Okay, so the question is, how do you ensure that the bandwidth from your data center up to the cloud is adequate? And I think that's something you would need to test and to measure and to have a good understanding of the existing traffic that's on that connection, and make sure that you understand how much is being used and then how much excess you have that you could actually use for pushing data up to AWS.
Great. Okay. Thanks for that. Another question for you. A related question. How does latency factor in when selecting a remote region?
Oh, so how does latency factor in? That's a great question, and I think it factors in, I'd say kind of a medium amount, because I don't think most of these storage operations are going to be highly latency sensitive. What you do need to think about if you're pushing large amounts of data from your location to ours is there are definitely efficiency considerations as you use TCP/IP over long-distance connections. A number of companies have put together some really interesting solutions that do what's called TCP/IP acceleration, or sometimes WAN acceleration, that can greatly speed up the process of moving large amounts of data across high latency connections.
All right, super. All right. Another question, let me just bring it to the fore. How we ensure to restore latency is within SLA parameters. How do we ensure restoring latencies within SLA parameters?
How do we ensure restore latency is within SLA parameters? I think that's going to be fairly specific to your particular application, but like almost any of these kind of situations, I would say that the best thing to do is to put a prototype together and then test it out, get a good sense of how much latency you're going to incur versus the amount of data that you need to restore. Measure that out, test it out in a couple different situations, and then you should have a pretty good sense of AWS's ability to help you out there.
All right, Jeff, do you support storage replication for Oracle ASM file systems, or would DataGuard be recommended? So the question's about supporting Oracle.
You support that? Okay.
Yeah.
Okay, so the question is supporting data replication with Oracle, and we do support Oracle RMAN on AWS, and there's more information about that on our website.
Absolutely. Yeah, it's a good point. Let's see. So there are questions. There are a couple of questions about HIPAA and PCI. I think you talked to that during your presentation. Maybe you just want to touch on, just clarify a little bit.
Okay, so with regard to both HIPAA and PCI, definitely a lot more information than I personally know about is in our white paper. One thing you should know about HIPAA is that HIPAA is done my understanding is it's done at the application level. So it means that we make the right information available to the folks that can actually build the HIPAA compliant application, but there's no such, there's no concept of us pre-certifying the environment to be HIPAA compliant. Instead, we provide you with the right information needed for you to actually go ahead and build a HIPAA compliant application. In addition to the usual data security things, I know there's a lot of issues about the ways that you use personally identifying information for database keys and so forth. I know we've had a number of customers go ahead and have built HIPAA applications running in the cloud. Once again, I would refer you to our website. I think if you go to the main AWS page, there's a box on the left that actually says interested in building HIPAA applications on the cloud. With PCI, we have gone through the certification process. There's a report that's available. There's some paperwork that needs to be done first for us to get that information, either from us directly to you, or more commonly, I believe it goes from us to the organization that you have engaged to conduct your PCI auditing. We're ready, willing, and able to help you with those kinds of situations. So please do not hesitate to get in touch with us to help out there.
Excellent. Okay, so there are a number of related questions again in the area of, I'm going to try and put it into one sort of Uber question, and that is, okay, so there are questions around backing up. So I've got data on tape, or I want to get it into S3. Can you elaborate on, just touch back again on when do I use AWS, and do I keep my tape, or do I just replace it outright? Am I doing incremental backups from now on, or do I? I think the question is, how do I assess, and how do I go about ingesting data?
Excellent. Okay, let me ponder that for just a second. So if you already have a large amount of data on tape, it seems like the best way to go moving forward would be you probably want to keep what you have on tape already on tape, and then moving forward, alter so that for a certain amount of time you're going to have a hybrid situation where older data is going to be stored on tape and new data is going to go to the cloud. As those tape-based backups become older and older, and you, at a certain point you say, we've already done full backups up to the cloud, you can get to the point of thinking about retiring your local storage and your tape drives. I know personally back in the earlier days of the PC, I spent far too much money on tapes and tape backups and the like that all had like a very, very limited lifetime. And I'm personally so much happier now that I can actually back up my hundreds of gigabytes of stuff into the cloud. So it's actually a fairly healthy kind of a thing at the point where you say, well, we don't need these expensive tape drives. We now have something that is now future-proof, and we don't have to worry about finding old hardware around just in case we need to get data off of old backup tapes. Okay,
thank you. So I have a question about Storage Gateway, maybe a clarification on whether Storage Gateway is providing interim location. Is it an interim location to store data, or does it back it up in real time?
Okay, so what happens with Storage Gateway is that when you create your gateway, you configure the gateway to access local storage. And you then configure it for access to S3 with you put your AWS account credentials in there. The first iteration of the gateway, the first release, gives you locally stored volumes where all the data is stored both on your local disk and is then copied up to S3. It's effectively a continuous process. As you're writing to the local volumes, we're watching those volumes for changes, and we're sending those changes up to S3. In a future release of the gateway, there'll be something that is effectively a cached volume, where the primary data can be thought of as being stored on S3, with data being brought down locally to your local machine as needed. I'd encourage you to tune into our gateway webinar for more details about that.
Good point. February 23rd, good plug. And some more questions about Oracle. So I just want to touch again, because we are getting more questions. So if you Google backup Oracle to S3 or Oracle RMAN to S3, you'll find a lot of resources on the Oracle site, some resources on our site. We're also, I just mentioned that we actually do that. Amazon.com is virtually eliminating tape backup for Oracle backups as we back up with RMAN directly to S3. Speaking with the IT ops guys, sounds like it was very simple to do, redirecting the channel from tape to S3, and it works seamlessly.
Indeed. So one thing you all might find very interesting about the way we do AWS is that we have this phrase internally we call drinking our own champagne. Mm-hmm. And that means that each of these different services that we put out for you to use, we are also good customers of those services. And we rely on all these different services to keep Amazon.com and all of our other properties up and running. So we're great customers, and our own business is heavily dependent on them.
All right, very good. So we have time for two more questions. Let us see. Related question maybe, how does it work with databases? Can we access our AWS resources via VPN and access them as a database on your site?
Okay, so can you access databases locally, or can you access databases remotely via VPN? Logically, yes, and that you can certainly open up the appropriate ports in the security group and you can access the database remotely. The trick is going to generally be latency, and most applications are thinking of databases as local and giving you probably latency in the order of low numbers of milliseconds. If you suddenly have a transcontinental connection from your application to your database, you're going to see somewhat different levels of performance and behavior, and that's simply just internet latency that you can't do a whole lot about. So logically, yes, you can get to that remote database. I'd encourage you to really try that out in practice and see how sensitive to latency your application really is.
All right, last question. We got a few good ones here. I'm sorry if I didn't get to yours, guys, but let me pick. How do we ensure backup? How about? Okay, this is relating to S3 and EC2 and performance and copying, I think, snapshots and restoring to EC2. How fast can data be transferred from S3 to EC2? Can you talk a little bit about that?
Okay, how fast does data go from S3 to EC2? So it's a very, very close, low latency connection. And I don't have a benchmark number I can give you. We monitor our networks continuously and make sure that we're never running out of capacity there. One kind of way that you might see that in practice is to simply put a bunch of data into S3 and to access it yourself and get a good sense of the very, very low latency you'll see from S3 to EC2.
Excellent, thank you. Okay, we're pretty much at the top of the hour. Before you drop off, though, we do have one more poll question for you, please. This is very important for us. It helps us with our feedback and making sure that we're delivering to you the types of information that's of value to you. So, last question very quickly. How relevant did you find the information in today's webinar? Pretty straightforward. And again, thank you everyone for taking time out of your very busy schedules for joining us today. Much appreciated. I'll let this survey run just for a few more seconds and share that with you. And with that, it will wrap up today's presentation. I'd like to thank you, Jeff, and thank you everyone for attending today's webinar. We will send a follow-up email with a link to this recorded presentation And if for those of you, it was a very heavily attended webinar, sometimes the audio suffers for that. For those of you that had audio or visual problems, the replay will be available on our YouTube channel, and it will have perfect audio. That will come to you in a follow-up email. And on behalf of Amazon Web Services, I'd like to thank you for joining us today to learn about how to use Amazon Web Services for your backup and recovery needs. And I'm looking at the poll results. I'm very encouraged by the fact that the majority of respondents by far got a lot of value out of the presentation today. So thank you very much. That concludes our webinar.